Hey everybody, lesson 5-2 or 5.2 here. In the immediately preceding lesson, we learned that if triangles are congruent, then you can say that their corresponding parts are congruent. In today's lesson, we are going to learn how can you conclude whether or not triangles are congruent. What do you need to know in order to conclude that triangles are congruent? In the previous lesson, in many of the homework problems, I simply told you, I wrote out a statement saying these two triangles are congruent to each other. And then you use that knowledge, that given information, to then conclude that, all right, there must be a specific pair of angles or a specific pair of segments that are congruent. But what if I don't tell you that triangles are congruent, and I want you to convince me how you know that the triangles must be congruent? What kind of information do you have to have? That's what we're talking about today, right? So here's one way to know that two triangles must be congruent. If the two triangles have three pairs of congruent sides, okay? We don't have to know anything about any angle measures in the triangles if we know that they have three pairs of congruent sides. Imagine that you have three sticks of different lengths, let's say 4 inches, 5 inches, and 6 inches, and you put them end to end like this. Well, I should have had a third pencil or pen prepared with me. And you put them end to end so that they form a triangle, okay, with lengths of 4, 5, and 6 inches. And then you get another 4-inch stick, a 5-inch stick, and a 6-inch stick, so that you're going to create another triangle whose sides are 4 inches, 5 inches, and 6 inches. Guaranteed, you're going to end up with another triangle that is congruent to the first one you made. It might be flipped over facing a different direction. We know that doesn't matter, okay? The triangles are going to be completely, as a whole, congruent to each other. And so we describe, we have a serious shortcut for saying if two triangles have three pairs of congruent sides. The huge shortcut looks like this. If S, 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 that three-letter acronym or abbreviation, each one of those S's stands for a pair of sides being congruent. So in other words, if we really expanded this, it might say if one pair of sides is congruent and then a second pair of sides is congruent and a third pair of sides is congruent, then the triangles are congruent. Okay? So if I give you a picture that looks like this one here, there are three pairs of sides marked congruent. You could say, well, then the triangles as a whole must be congruent. Because if three pairs of sides are congruent, then the triangles as a whole are congruent. Okay? Now, if you have three pairs of congruent angles in two triangles, but you know nothing about any of the sides, then there is no guarantee that the triangles are congruent. And here's an example to show you how it's possible for two triangles to have three pairs of congruent angles, and yet the triangles are clearly, visibly not congruent to each other, right? They could both have angle measures of 20 and 70 and 90 degrees, but look at how much larger the segments are in this second triangle than they are in the first triangle. This is just a bigger, it's an actually bigger triangle. It's like a larger version of this one down here. It's like you took this one picture of that, and if it was on your phone, you do this kind of thing and you enlarge it, right? So it is very possible for two triangles to have three pairs of congruent angles, but that does not lead to congruent triangles. there's an arrow with a double line through it. Okay, I think you understand what that would mean. We don't ever really use that symbol in math, but 3 pairs of congruent angles is no guarantee that triangles are going to be congruent. Okay. Well, what about other combinations of 3 pairs of congruent things? What if we have some congruent sides and some congruent angles? Maybe not 3 of either one, but maybe 2 of one and 1 of the other. Like, what if we have 2 pairs of congruent angles and 1 pair of congruent sides? So in this first diagram here, that's what I've got. I've got a pair of congruent angles here. I've got a second pair of congruent angles there. And then I have a pair of congruent sides. Okay. Well, if you have 2 triangles with that combination of congruent parts, a pair of angles and a pair of sides and a second pair of angles, if you have that, that is a guarantee that the triangles are congruent. They would have to be. Okay. And here's another example where I've got 1 pair of congruent angles, a second pair of congruent angles, and a pair of congruent sides marked. Okay. And that also guarantees congruent triangles. But there is a slight but important difference to mathematicians in how we would describe the congruent parts in these 2 triangles as opposed to how we would describe them in these 2 triangles. In this case, we would say, I got a pair of congruent angles, I got a second pair of congruent angles, and I have a pair of congruent sides. You see how I wrote the S not in between the 2 A's here? I wrote it to the side of the 2 A's. That's an important distinction for mathematicians. It's not one that's going to be important to us. I'm going to tell you right up front, this is a situation that we are simply not going to deal with. I am choosing not to confront you with this situation and how it is different from this situation. It's a little detail about congruent triangles that we are going to skip over this year, partly due to the whole remote learning situation. Okay. But in this situation, I want to explain the difference briefly and then we're going to move on. Notice how the one side that is marked in this triangle is the side that actually connects to both of the angles that are marked in that triangle. It's a side that's actually part of each one of those angles. It's a side that we usually say is between the 2 angles in the picture. The one side that is marked in this triangle right here is the side that is between the 2 angles. If I had marked this side up here, that side is not what we say between the 2 angles. All right. And that's the kind of situation that I have in these triangles on the right. This side, which is the one side that is marked, is not really between these 2 angles. This is the side that is between those 2 angles. And so we describe this collection of congruent parts by writing the S after the 2 A's, not in between the 2 A's. Okay. But again, it's not something that we're even going to deal with in this unit. And so I don't want to really linger over it that much. What about if we have 2 pairs of congruent sides and 1 pair of congruent angles, which is kind of the opposite of what we just did in this row here, 2 pairs of congruent sides? Well, here's a situation where I've got a pair of congruent sides. I got a pair of congruent angles, and then I've got another pair of congruent sides. And that does guarantee congruent triangles. Okay. Over here, I've got a pair of sides. There's a pair marked congruent. I've got another pair of sides marked congruent. There they are. And I have a pair of angles marked congruent. Okay. But again, this situation on the right here is a little different from this situation on the left. Different in a very important way to mathematicians, and different in a way that's going to be important to us. You need to pay attention to this difference. It's kind of like the difference I was describing up here. This one angle that is marked in this diagram is not how we would say in between these two sides. There's three angles in that triangle, right? Only one of the angles in that triangle is in between those two red sides. It's the one angle that is formed by those two sides. That angle that I just arced in blue, that's the only angle that is between those two red sides. Okay? The angle that I originally marked is not in between those two sides. So we describe this combination of congruent things this way, SSA, and the A is not in between the S's because this angle is not in between these sides. But I am telling you that that angle is congruent to this one, which is also not in between the two congruent sides marked. The one angle that would be in between this side and this side, where's the one angle that's between those two sides? It's this angle right there. The angle that those two sides are actually forming is the one angle that's between those two sides. Okay? And again, this is something you've got to recognize, the difference between this situation on the right where the angle is not between the two sides and this situation on the left where the angle is between the two sides, because this combination of congruent parts does not guarantee congruent triangles. It doesn't. Whereas this combination does. Both of those combinations are two pairs of congruent sides and one pair of congruent angles. But it's only when the angles are in between the sides that we can know for sure the triangles have to be congruent. Right? Now, some of you might be looking at this picture on the right and thinking to yourself, wait a minute, Mr. Nortillo, I see that you marked this segment congruent to this one. But that's about what a horrible picture that is. Those two segments do not look congruent to each other. I challenge you, take a little tape measure with millimeter markings on it and hold it up to your computer screen right now and measure those two segments. You will find out that they are equal to each other in length. They may not look congruent to each other. That is just an optical illusion. And it's an optical illusion you may have seen before. If I draw two congruent segments like that, there, those are congruent, wouldn't you agree? But I draw a couple of lines on this one like that, and then a couple of lines on this one like that. Suddenly, it may look to some people like this segment is longer than this one. Maybe it doesn't to you in this case, but if you used to just start spinning the pictures around, all of a sudden it gets hard, puzzling, confusing. I'm telling you, those two segments are congruent to each other. And I'm telling you, you can take a tape measure up to the screen and measure that blue segment and measure that one, and you will find that they really are the same length, truly. Okay? And you can do the same with the angle here. If you had a protractor, you could measure those angles. They are congruent to each other, but the triangles as a whole, clearly not congruent to each other. So it is possible to have this combination. My stylus just went dead. It's possible to have this combination of congruent parts of two triangles, and still the triangles are not congruent. Okay? So summarizing in the yellow box here, you might imagine this yellow box is extremely important, okay, because of the previous yellow boxes we've had in other notes. If any of these three conditions exist, any one of the three about two triangles, then the triangles are congruent as a whole. But you have to know also that these two sets of conditions do not guarantee congruent triangles. And then again, this last condition, We're just not going to worry about that. Not going to have any problems where you have to think about that. Okay? Now, I say you have to know these things, but again, you could be using your notes in all of these problems. And so you don't have to commit which conditions guarantee congruent triangles. You don't have to commit that to memory and which conditions don't, but you do need to recognize the difference between how this looks and how this one looks, because they look different. Okay? So let's do a few more proof problems where we're going to use these new reasons to prove that triangles are congruent. And the last homework assignment, I was always telling you triangles are congruent and asking you to prove some other information from that. Well, I wasn't always telling you that, but I was often telling you that. Okay? And now in this problem, I want us to prove that triangles are congruent. And notice something different about this first example problem here. You notice anything different over here on the left-hand side? Again, my stylus has gone dead. If you're really observant, if you've really been paying attention to the proof problems, come on, stylus, you'll notice something different there. I did not give a statement. I didn't put a number 2. Okay? I know, it's a small detail. You should put a number 2, but I am no longer anymore going to put a number 2. Okay? Either there or over there. And the reason I'm not going to do that is actually really important, because from now on, the proofs might go beyond a step 2. The proofs might require a step 2 and a step 3 in order for you to get to the statement I'm asking you to get to. And I am not ever going to tell you how many steps a proof is going to take. Not in any more homework problems, not on the next quiz or the test. If you chat me during the next quiz or the test and say, Mr. Nortillo, how many steps should this problem take? I'm not telling you, okay? It will be, that's like me giving you a diagram and asking you to find an angle measure, and you asking me, Mr. Nortillo, how many steps should it take me to find this angle measure? I'm not telling you. You just find it. It'll take however many steps it takes you. Maybe you'll need to find 2 other angle measures before you find the one I'm asking you. Or maybe you can find the one I'm asking you to find right away. I don't know. You figure it out. It'll take as many steps as it takes. Okay? So there's got to be a step number 2 here. And there might have to be a step number 3. Now, here's something I think I said in the last video, and I said it's going to be important. It may not truly have been terribly important in the last lesson or homework, but man, does it become important here. Okay? Anytime I give you statements about congruent objects, you should immediately add congruent marks into the picture. Okay? You don't need a reason to do this. I mean, I'm telling you certain things are congruent. So you're just putting in the picture what I have already written out for you. Okay? And you absolutely need to do that. So I'm telling you that AB is congruent to DE, you should mark them. AB congruent to DE. I'm telling you that AC is congruent to DF, you should mark them with a different set of marks, not the same single tick mark. Otherwise, you're going to confuse yourself about what is congruent to what, right? If you use a single mark for the first pair of congruent segments, don't use a single mark for the next pair. And I've also told you that angle A is congruent to angle D. Let's mark those. I'll use a single arc. Okay, there. I put all the marks in the picture. Okay. Now, if we're going to prove that 2 triangles are congruent, we need one of these 3 sets of conditions. One of those sets of conditions has to exist. It has to be present in order for us to say the triangles are congruent. Do we have any of those sets of conditions right now? Do we have 3 pairs of congruent sides showing up in this picture? No, we don't. We only have 2. Okay. So what about this? Do we have 2 pairs of congruent sides and a pair of congruent angles in between them? Yes, we do. So we can say triangle ABC is congruent to triangle DEF because If we have a pair of congruent sides and a pair of congruent angles and another pair of congruent sides, and the angles are in between the sides, like they are in this triangle and the other one. There's the two sides, the angle is between them. Then the triangles are congruent. Okay, so there we managed to prove this statement in only one step after the given information. This proof only went one step of work beyond what I gave you. Okay, but other proofs might require more than one step, like the next example that we're going to do. So here's the next example, and here's an updated yellow box, okay, with these 3 new reasons down here at the bottom of the yellow box. And before we go on to do this next problem, let me tell you this. Every single homework problem, quiz problem, and test problem that you get from here on out, the whole rest of this unit, you are going to have to prove that triangles are congruent. Okay? Now, that is the nature of every problem in tonight's homework. What I mean by that is I am going to specifically order you to prove that triangles are congruent. Starting in the next lesson, I'm not going to order you to prove that triangles are congruent. But in order to prove what I am asking you to prove, you will first have to prove that there are some congruent triangles somewhere, and then use that fact to go on to prove what I've asked you to prove. So let me say this again. Every single proof problem from here on out for the next 2 weeks, okay, you're going to have to prove that triangles are congruent. You're going to have to use one of these 3 reasons somewhere in the proof. Okay? And these are the only 3 reasons we're going to have. We're not going to add any more. Okay? As far as proving that triangles are congruent. So you're going to be using these so many times, I think you're going to get really, really good at them pretty quick. Let's look at problem number 2. All right. Oh, there's a letter missing up here somewhere. T-O-Y-T-A-K. Actually, I guess not. I guess this diagram doesn't really need a letter, an extra letter up there, but I'm going to put a letter up there anyway. Let's put an M up there. I don't think that point needs a name, but all right. Again, first thing you should do is any things that I've marked congruent or I've told you are congruent, you should illustrate in the diagram. Angle TOA. Oh, that should be a T up at the top. I did need a letter there, and it must have accidentally gotten erased. So let's go back and make that a T. Okay, so now angle TOA, that's this one, congruent to angle TAO, that's that one. Segment TY congruent to segment TK, segment TY congruent to segment TK, and finally segment YO congruent to segment KA. All right. We are trying to prove that triangle TOY is congruent to triangle TAK. We only have 3 ways to do that. And again, by that, what I mean is we are looking for one of these 3 sets of conditions. 3 pairs of congruent sides, 2 pairs of congruent sides and a pair of congruent angles, or 2 pairs of congruent angles and a pair of congruent sides. Do we have any of those sets of conditions in this problem here? You might be quick to say yes, but the answer is no. The answer is no. Yes, we have 2 pairs of congruent sides. And yes, we have 1 pair of congruent angles. But look, I am going to circle these congruent triangles again in green, and I'm going to trace them in the diagram in green. Triangle TOY and triangle TAK. There. Okay. Those are the triangles we're trying to get congruent. We need 3 pairs of congruent parts of those triangles. These segments that are marked congruent, that you were told congruent, they are parts of those green triangles. And these segments that are marked congruent to each other, they are parts of those green triangles. But do you see the pair of angles that are marked in red? They are not parts of those green triangles. They're not. I mean, they're attached to the triangles, but each one of those red angles is outside of the triangle, right? I mean, let me just draw you a little picture over on the side here. Here's a triangle. This angle here is not a part of this triangle. The parts of the triangle are the sides of the triangle and the angles that are inside the triangle, not outside the triangle. Okay? So right now, what we have is we have a pair of sides congruent and we have a second pair of sides congruent, but we do not have a pair of congruent angles in the green triangles. So we are not ready to say that these triangles have to be congruent. I've asked you to prove the triangles are congruent. We don't have enough information to do that right now, which means we have to get more information. We have to prove that there is some other pair of congruent parts in those triangles so that we have 3 pairs of congruent parts in those triangles. And the challenge of this problem is, how can we get another pair of congruent parts? Can you give me a convincing reason why, for instance, maybe this angle would have to be congruent to this one, or maybe that angle would have to be congruent to that one, or maybe this angle would have to be congruent to that one, or that maybe this side would have to be congruent to that side? Can you give me a convincing reason for why any of those pairs of things would have to be congruent? Well, here's the answer to that. I mean, I would pause and ask you about this in class, okay? But I can't wait for anybody to answer here. So I'm just going to tell you, all right? You can pause the video and think about it if you want, but here's the answer. The only pair of congruent things that we can get are these 2 sides. And the reason that we can guarantee that, oh my gosh, why does my stylus die right in the middle of writing? The reason that we can guarantee that segment TO must be congruent to segment TA is this reason right here. I'm going to use the text box. Number 2, if a triangle, the one in the middle, triangle TOA, if a triangle has 2 congruent angles, then it has 2 congruent sides. This is not news to you. This is a reason that's right here in the yellow box. Where is it? If a triangle has 2, here it is right here. If a triangle has 2 congruent angles, no, for some reason I'm not able to highlight that. If a triangle has 2 congruent angles, then it has 2 congruent sides. Okay, it's a reason we might not have used a lot. Oh, that should be step 2. Why does that say 1? And how come I can't change it? 2. Why is it? When I hit the space, that's so funny that that text box changes. 2. If a triangle has 2 congruent, and I should spell congruent correctly, angles, then it has 2 congruent sides. Okay, that's it. That's our only choice here. That's the only thing that we can do. You cannot give me a convincing reason why any of the angles in those green triangles has to be congruent. It simply cannot be done. Okay, but now that we have declared with a good reason that these 2 segments are congruent, what should you do? You should mark them in the picture. 1, 2, 3, triple mark. 1, 2, 3, triple mark. Because once you add the marks to the picture, now you can see, oh, look at this. I've got one pair of congruent sides that was given to me. I got a second pair of congruent sides that was given to me. Now I got a third pair of congruent sides that I established on my own. And so now I can say that the triangles are congruent. I really got to figure out why this stylus does this to me. It's probably something that I'm doing. Triangle TOY is congruent to triangle TAK. Why? Because if SSS, then the triangles are congruent. Okay? You cannot use this SSS reason until you have 3 pairs of congruent segments stated in your statement column. Remember this about reasons in general? The hypothesis of the reason must be something that is already true. Okay? How do you know if it's already true? Look at the statements in your statement column and see if you can find statements like that, right? This S, you got to be able to connect that to a pair of congruent sides. Well, there. This S, you got to be able to connect that to a pair of congruent sides. And this third S, you better be able to connect to a third pair of congruent sides. If you can't, you are in no position to use this reason to tell me that triangles are congruent. Let's move on. Here's another example. I want you to prove that triangle TMZ, let's trace it, TMZ is congruent to triangle WGN. Those are the triangles I want you to prove are congruent. So we got to get 3 pairs of congruent parts in those triangles. Now, what have I given you? I've given you that angle TMZ congruent to angle WGN. Let's mark those. I got a written statement about it. Let's illustrate it. Angle MTZ, GWN, that's this angle up here. I'll use 2 arcs for that one and 2 arcs for that one. And then finally, triangle TMI congruent to triangle WGI. These are not segments or angles that I'm telling you are congruent. These are entire triangles. We really don't have a convenient way to mark that 2 triangles are congruent. Perhaps you could do something like this. These 2 triangles as a whole are congruent, okay? Or maybe it would look even better if we drew those arrows like inside the triangles. Those 2 triangles are congruent as a whole. That does not really warrant you adding any marks to the picture, okay? So you can see in the red triangles, I only have 2 pairs of congruent things, and they're both angles. I got 1 pair of congruent angles. I got a second pair of congruent angles. If I'm going to say that these triangles are congruent, I need 3 pairs of congruent things. Always, 3 pairs of congruent things. And here's our choices. And look, here's the one reason that includes 2 pairs of congruent angles. But it requires a pair of congruent sides. And right now, we have no statement about congruent sides in the red triangles. We need to come up with one. And we need to come up with a reason, a convincing reason why. Again, I would let you think about this, but I'm just going to go ahead in the video and say, here's what we can say. We can say that side TM is congruent to side WG. And why is that? Because if triangles are congruent, wait a minute. Isn't that what we're supposed to be proving, that triangles are congruent? But this means I'm already supposed to know that triangles are congruent? Oh, yeah. Well, see, this hypothesis is referring to these triangles here. The triangles in the middle, the white ones. They have been told, you've been told that those are congruent. And if those triangles are congruent, then their corresponding, I'm going to abbreviate that, corresponding parts are congruent. Okay. Now, they have all kinds of corresponding parts, but the parts that are going to help me with this problem is that segment and that segment. I mean, yeah, I could say that these two segments are congruent, but that's not useful to me. I could say that these segments down here are congruent. That's not useful to me. I could say that these angles are congruent. None of those parts are useful to me in this problem. Okay? So they're kind of a waste of time to talk about. The useful parts are sides TM and WG, which are parts of these triangles here, and they're also parts of the triangles that I'm trying to prove are congruent. And so now that I have established that those two sides are congruent, now I can say that the red triangles, triangle TMZ, is congruent to triangle WGN, because now I have not SAS, but ASA. Then triangles are congruent. And again, you are in no position to use this unless you can circle every one of those letters and connect it back to a specific pair of congruent things in your statement column. So, can I do that with this A? Yeah, there's a pair of congruent angles. And with this A, there's a pair of congruent angles. And then this S, there. You see? If you can't do that, if you can't trace every one of those three letters in one of these abbreviations back to the statement column, pointing to a specific pair of congruent things, you're not ready to use this reason. You don't have the information that you are already supposed to have. Okay? So this problem also took 2 steps of work beyond the given information. Let's do one last example. I'm going to work through this one even more quickly. I want to prove that these two triangles, the only two in this picture, are congruent to each other. I have angle DTE, that's this one, congruent to angle KTL. Mark them. Angle DET, congruent to angle KLT. Mark those. Okay. And then finally, DK bisects EL. All right. Well, that is not a statement about congruent anythings. It's a statement about bisecting. Okay. And so all I have in this diagram is a pair of angles and a pair of angles. I got no other pairs of congruent parts. Okay. I'm not ready to say that these triangles are congruent yet until I get a third pair of congruent parts. And the third pair is going to come from this statement. If DK bisects EL, well, if a segment in general bisects another segment, what does that do? What does that mean? Then it divides that segment into 2 congruent segments. Right? And so what are the 2 specific congruent segments? They would be ET congruent to TL. And now once you've written that statement down, go add marks to the picture. Because now you can see in the picture, oh, I've got 2 pairs of congruent angles and a pair of congruent sides between them. So now we can say that triangle TED is congruent to triangle TALK, sort of TLK. And the reason is if ASA, then triangles are congruent. Okay? In the homework tonight, as I said earlier, some of the problems, okay, I might have given you all the information you need. And in the very first step after the given information, you can tell me why the triangles must be congruent, because I will have given you 3 pairs of parts in a proper combination. And some of the problems are going to require you to find a third pair of parts before you can say that the triangles are congruent. And I'm not going to tell you which problems are which. I'm not going to tell you how many steps each problem takes. That's part of the challenge of doing these problems. But again, it's just like part of the challenge of finding angle measures from problems a long time ago, right? I mean, it didn't bother you then. Nobody was asking me how many steps should this take then. It takes how many it takes, all right? So get after the homework, and we are probably going to spend a fair amount of time in the next Zoom session talking about the answers to these before we move on. Okay, good luck.